This is the sixth question of exercise 3.2 of the chapter Lines and Angles of class 9. The question given here is in figure 3.33. That is this picture 3.33. The figure 3.33. PQ and RS are two mirrors parallel to each other. That is, PQ is one mirror, RS is another mirror which are parallel to each other. An incident ray AB strikes the mirror PQ at B. Means a ray, a light ray, for an example, a light ray which incident or which touches, which strikes at B reflects towards the path BC and strikes here RS somewhere at point C and again reflects through the path CD. Okay, now what we have to prove is AB is parallel to CD. Okay, so we have to prove that AB is parallel to CD. For that, what we have to do first is draw normal to B and C. Let this be a normal drawn to point B. That is, let this be something like BX and a normal here for C. Let this be something like CY. See, these normals are perpendicular to the parallel lines. Okay, now this BX is perpendicular to RS and PQ, and this CY is perpendicular to PQ and RS. Okay, now see, this is the angle called angle of incidence. Okay, so let this be something like A, and this is the angle called angle of reflection. Let this be something like B. Okay, same here. A and X. So here it will be something like angle of incidence and here angle of reflection. Okay, that's it. But we know that angle of incidence will be always equal to angle of reflection. Okay, so angle of incidence, that is ABX, angle ABX will be equal to angle XBC. Why? Because angle of incidence, this angle will be always equal to angle of reflection. So what I can write here, angle ABX is equal to angle XBC. Okay, so what is the reason? Angle of incidence. Angle of incidence. Angle of incidence is equal to angle of reflection. Angle of reflection. Okay, now so ABX means what? ABX is nothing but let this be something like A and A because they are equal. A and this is X. We don't know what exactly the angle, X and X. Okay, so equal. And now here similarly angle BCY is equal to angle YCD. Angle YCD. Reason same. So angle of incidence is equal to angle of reflection. So since these two are equal, I consider this as A and this also A. And here these two are same and I consider this as X. So here also X. Both are X and here both are A. Okay. Now see, this is the line perpendicular to RS and PQ, and this is also a line, that is a normal perpendicular to RS and PQ, where this YC is parallel to BX. Okay, so we can write that as BX is parallel to CY. If BX is parallel to CY and BC is okay, BC is the transversal, then see A and X will be interior alternate, which will be always equal, is it not? Yes, see here, BX is parallel to CY and BC is the transversal, so that here A and X, that is XBC, will be equal to YCB, because these two angles are interior alternate angles. Okay, now how to write here? See, this as XBC. Okay, now so angle XBC is equal to this angle, that is YCD. Okay, angle YCD. So this XBC is equal to YC, not YCD, sorry, BCY. Okay, now BCY. Angle XBC is equal to angle BCY. BCY, because BX is parallel to YC and BC is transversal, so that interior alternate angles will be always equal. Therefore, A will be equal to X. A will be equal to X. So this will become A and this also will become A. So in place of X I can write A and A. Okay. Yes, A is equal to X. Now angle ABC, angle ABC will be equal to angle BCD. BCD. How? This ABC, that is, let me write here, angle ABC is nothing but angle ABX plus angle XBC will be equal to angle BCY plus angle YCD. See here, ABC means ABX XBC. Okay, now, and BCD means, that is BCY plus YCD. Okay, ABX means what? A. XBC means what? A, is equal to BCY means X, of course, but here A is equal to X, so I can write here A, and here this is also A. So A plus A, 2A is equal to 2A. So ABC means angle ABC is 2A, angle ABC is equal to 2A, and angle BCD is also equal to 2A. Therefore, see here, if this is 2A and this is 2A, see, this is the line AB and this is the line CD, and this will be the transversal. Okay, if BC is transversal and interior alternate angles are equal, then surely AB is parallel to CD. So I can write here, therefore AB is parallel to CD. So reason is interior alternate angles are equal. So here interior alternates are these two, sum of these two, that is A plus A, 2A, and these two, X plus X, but X is equal to A, and then X is equal to A we have proved here. So A and A plus A, 2A. So here 2A and here also 2A. Therefore interior alternate angles are equal. If interior alternate angles are equal, then surely AB and CD are parallel. So hence proved. This is the procedure to solve the problem.